Thank you everyone for joining us. We're finally ready to start. Our first speaker is Lukas Nakamura, who will tell us about a metric on the contactomorphism group of an orderable contact manifold.
Yes, thank you very much for the invitation. So as the title suggests, I will talk about pseudo-metric on the contactomorphism group, which turns out to be related to the orderability of the contact manifold. So first, some basic notions. So M will be a connected manifold of dimension 2n+1 together with a contact form on it, meaning it's a one form which satisfies that alpha wedged alpha to the n is a volume form. Cont 0 will denote the identity component of the group of compactly supported contactomorphisms, meaning those diffeomorphisms which preserve the contact structure, which is the kernel of the contact form alpha. And given an isotopy through contactomorphisms, we can associate to it a function by evaluating its time derivative, evaluating alpha on its time derivative. And it turns out that this defines a one-to-one correspondence between contact isotopies starting at the identity and time-dependent functions on M. And the isotopy corresponding to the constant function 1 is called the Reeb flow. So since we have this correspondence between contact isotopies and time-dependent functions, we can study the identity component of the contactomorphism groups via the Hamiltonians. And one important notion is that of a non-negative or positive path of contactomorphisms, which are those which are induced by a positive or non-negative Hamiltonian. So this notion of positive and non-negative paths induces quasi-orders on the contactomorphism groups. Namely, we say that phi 0 is smaller or equal than phi 1 if there exists a non-negative isotopy from phi 0 to phi 1, and we say that phi 0 is smaller than phi 1, and with this this other the symbol if there exists a positive isotopy. And these are in general not partial orders, but if it is a partial order, M is called strongly orderable. And Eliashbeck and Poltorovic gave a criterion which ensures that M is strongly orderable, namely if M is compact, then M is strongly orderable precisely when there does not exist a loop of contactomorphisms, a positive loop of contactomorphisms. So using the this quasi-order, we can define intervals in the contactomorphism group. Namely, if we have two contactomorphisms, phi 0 and phi 1, we say that phi 0 is smaller than phi 1 if it lies in between them with respect to this quasi-order. And these are some subset of the contactomorphism group, and so they generate some topology called the interval topology. And it is easy to see that if there exists a positive loop of contactomorphism, then actually any two contactomorphisms in this group can be connected by a positive path, meaning that these intervals are actually equal to the whole contactomorphism group, and therefore the interval topology is trivial. But if there does not exist a positive loop, then these topologies might be interesting. And Chernov and Nemirovski, who were also the people that introduced these interval topologies, ask whether, in this case, these interval topologies are always Hausdorff. And what I will explain later is that, in fact, if M is strongly orderable, these turn out to be metric. But before that, so I want to talk about the energy of contactomorphism, namely, since we have a contact form, we can associate Hamiltonians to contact isotopies, and we can use those to measure the energy of a contact isotopy. So the Shelukhin-Hofer energy of a contact isotopy will be is defined as the integral over the maximum of the absolute value of the Hamiltonian over time. and where the H is the Hamiltonian, which generates this contact isotopy. Using this notion of energy, we can define the distance between two contactomorphisms by minimizing the energy that is required to go from phi 0 to phi 1. And this always defines a pseudo-metric on the contactomorphism group, but in fact, Shelukin showed that this Shulukin-Hofer distance is actually a metric, meaning it is non-degenerate, and it is also right invariant and left natural. And left naturally in this case means that if we act from the left by a contactomorphism psi, then again we get the distance, but with respect to a different contact form, namely the pullback of alpha with respect to psi. So we will be interested in also other energies, namely if we take Hamiltonian, then we define plus or minus energy as the integral over the maximum of the Hamiltonian or the maximum of minus the Hamiltonian, which is the same as minus the minimum of the Hamiltonian. And again, we define some kind of notion of distance, which is denoted by delta plus minus, by taking the infimum of these plus minus energies over all contact isotopies which go from phi 0 to phi 1. And in fact, these can be rewritten in the following way, namely delta minus of two contactomorphism is the infimum over all real numbers epsilon, so that there exists a Hamiltonian which is at least as big as minus epsilon, which induces a contact isotopy from phi 0 to phi 1. And so there's a type which should be phi 1 of phi h1 of phi 0 is equal to phi 1. And similarly for delta plus can be written in the same way as the infimum over epsilon, so that the Hamiltonian is at most as big as epsilon. And it's also easy to see that phi plus of phi 0 and phi 1 is equal to, so delta plus of phi 0 and phi 1 is equal to delta minus of phi 1 and phi 0. So now we want to define a pseudometric using those. Of course, the delta plus minus are never like pseudometric in any way. For example, they're not symmetric, and also they can be negative. But if we define the alpha of two contactomorphisms as the maximum of delta plus, delta minus, and 0, then this defines a pseudometric on the contactomorphism group. Before stating the main result about this pseudometric, I want to remark that in the case of compact M, the definition of delta plus minus and the alpha appeared first in the PhD thesis of Louvre. And if we define to alpha as the maximum of minus delta minus and 0, then this was introduced under the name Lorentz distance function by Hedeke, and he also proved several properties of this Lorentz distance function. Okay, so now to the main result. So the alpha turns out to again be a right invariant and left natural pseudometric, but it may be degenerate. And in fact, if it is degenerate, then it vanishes identically automatically. Furthermore, if we have a compact M, then we know that it is non-degenerate precisely when M is strongly orderable, and its metric topology agrees with the interval topology. And furthermore, it's always bounded by the Shulukin-Hofer distance, simply because it measures like only the maximum or the minimum of the Hamiltonian separately, but those are always bounded by the absolute value of the Hamiltonian. So the maximum of the absolute value of the Hamiltonian. Right, so next I want to discuss Legendrian submanifolds. So a Legendrian submanifold is an n-dimensional submanifold which is every tangent to the contact distribution. So one important fact about Legendrians is that any isotopy of Legendrian submanifolds is induced by an ambient contact isotopy, and therefore whenever we have a notion of energy of like contact isotopies, then we get an induced notion on Legendrian isotopy classes. Namely, if we take two Legendrians, and the contact isotopy, which moves one to the other, we can take its Hamiltonian, restrict it to the underlying Legendrian isotopy, and like measure the energy using that Hamiltonian, this restriction. And in this way, we can again define this delta plus minus, and we sum d alpha, which is the maximum of delta plus, delta minus, and 0, which again defines some pseudo-metric on the isotopy class of the Legendrian. And again, we can define the notion of positive or non-negative parts of Legendrian. And if L is so we again have a notion of orderability, namely these quasi orders should be partial orders. And for compact L, it again turns out that L is strongly orderable precisely if there does not exist a positive loop of Legendrians in this Legendrian isotopy class. And I think this was first noted by Chernov and Nemirovski that this is the case. So now we have a similar result to before for Legendrian isotopy classes, namely this d alpha is again a right invariant and left network pseudo-metric. And if L is connected, we know that it is either non-degenerate or vanishes identically. If L is in addition also compact, then it is non-degenerate precisely when L is orderable. Furthermore, we know that the interval topology, which again is induced by these intervals with respect to positive paths, agrees with the metric topology induced by this d alpha. And again, it's bounded by an analog of the Shelyukhin-Hofer distance, which is called the Shelyukhin-Chekhanov-Hofer distance. Yeah, and now I want to remark that because these energies or distances are defined by looking at energies of isotopies, we can also define analogous distances on the universal cover of either the contactomorphism group or on the universal cover of a Legendrian isotopy class. Namely, we just keep track of the homotopy classes of paths. But in this case, we need to replace the positive loop by contractible positive loop because we need to know the homotopy class. But one problem is that we cannot conclude that so we have analogous results, but one cannot conclude from the methods that these are non-degenerate. But one can only conclude that the distance between two lifts of two different elements of either the contactomorphism group or the Legendrian isotopic class is positive. And for the this is also known for the Shelyukhin-Hofer distance, and that was also remarked already by Shelyukhin that one only gets this weaker version of non-degeneracy, and that the general problem is probably much more difficult. Right. So lastly, I want to discuss the relation of these distances to the Reeb flow. So one can show that if we act with a time t Reeb flow inside of delta plus minus, then this changes delta plus minus precisely by adding plus or minus t. And the same is true for Legendre. So I here assume orderability so that these quantities are finite. So if L is strongly orderable, then again, if we act with the time t Reeb flow on the one of the Legendrians, then this acts on this delta plus minus by just adding plus or minus t. And again, for the if we formulate the corresponding result for the Lorentzian distance function I mentioned earlier, then this was also already shown by Hedeker. So this has the following consequence, namely, if we take if we assume orderability and take the distance from the identity to the time t Reeb flow, then what I said earlier implies that the d alpha distance is equal to the absolute value of t, and because the Shelyukhin-Hofer distance is also bounded from below by this distance, the same follows for this because the upper bound just comes from the Reeb flow itself. And it turns out that this is an if and only if statement. So M is strongly orderable if and only if this is the case. And here, of course, I assume compactness of M so that the Reeb flow is a compactly supported contactomorphism. And similarly for orderable Legendrians, we have that if we take the distance from L to its image on the time t Reeb flow, then it's also equal to the absolute value of t, assuming appropriate completeness of the Reeb flow again. And if we combine this with the following result, then it has an interesting consequence. Namely, we know that if we have a loose Legendre with a loose chart of size c and the Reeb flow is complete, then the distance from L to its image under the time t Reeb flow is actually uniformly bounded by this constant c. And here the size of the loose chart is up to a factor of 2, the energy that is required to create a loose chart in an arbitrarily small Darboux ball, which roughly you can think of as the energy that is required to shrink one of the loose charts. And there's always some finite number. And it roughly corresponds to the action of a Reeb chord in the loose chart. So if we combine these two observations, then it follows that if we have a Legendrian with loose chart of some size, then the Legendrian cannot be strongly orderable. And this gives another proof of this result, and which was first proven by Leo using very different methods. But in fact, we can say even more. So why is it true that strong orderability implies that this distance is equal to the absolute value of t? Well, if it were smaller, then we could find an isotopy from L to its image under time t Reeb flow of energy less than t. And let's assume t is positive. Then we can compose this with the negative Reeb flow of time t, and thereby create a negative loop of contactomorphisms. And thereby we also have a positive loop of contactomorphisms by going through it backwards. And because we have this explicit construction and this explicit upper bound, one can get an explicit upper bound for the energy of a positive loop. Namely, if we have a loose Legendrian with a loose chart of size c and the Reeb flow is complete, then we can find a positive loop whose energy is bounded from above by 2c plus epsilon for any positive number epsilon. Okay, so the last thing I want to remark is that in the case that M is closed or that L is closed and the Reeb flow is complete, the two main results I presented were also independently shown by Ali and Aluf. And in fact, they showed that if we take plus minus delta plus minus of two Legendrians, then this always takes values in the actions of Reeb chords from L0 to L1. And in that sense, it is spectral, and they called this the spectral distance. All right, this is all I want to talk about. Thank you very much for listening.
Thank you so much. Any questions?
So is there any relation between the metric which you defined and topology which you got, right, from Chernov and Nemirovski with being invariant situations? So sometimes in groups of contactomorphisms, there are Sandon time metrics which are being invariant. So can you say something about this?
Sorry, can you, I had some problems. Can you repeat the question again?
Yes, so in certain situations, there are being invariant metrics on contactomorphism groups from metric of Sandon, right? And you can also talk about topology and so on, and this metrics also somehow respect the order. So what is the relation between your metric and
like, is this actually, if this Fraser-Poltrovich-Rosen metric is defined, it's actually closely related to that, which is and in fact, it's like always lies between that metric and like the Fraser-Poltrovich-Rosen metric and this Fraser-Poltrovich-Rosen metric plus one. So and this is, well, it kind of makes sense, right? Because because that metric would say like it's like bigger than the Reeb flow, like the corresponding Reeb flow for some time, and in fact, Ale and Alouf also define their spectral selectors as like some continuous version of this Fraser-Podrobich-Rosen metric. So in that sense, they are closely related, actually.
Thank you.
Any more questions? Okay, if not, let's thank Lukas again.